Okay, so I'm going to go back and talk about 8C. 8C is log of 0.004. Okay, so log of 0.004 or 4 thousandths. So when I look at my chart, I don't have that, but I do have 4. So I know that log of 0.004 is 4 times 0.001. And then when I think of scientific notation, I know that that is 10 to the negative 3. So let me stop right there. That's 10 to the negative 3. If my decimal point originally started here and I made 1, 2, 3 moves, that's 10 to the negative 3. So now that I got 4 times 10 to the negative 3, I got log of 4 plus log of 10 to the negative 3. Now remember, that's one of our properties that we talked about. That if I have something that's being multiplied, I can split it up. So that's what I did. Now log of 4 is on the chart. Log of 4 is 0.6021. Now here's where it gets tricky. Log of 10. If it's just log with no base, what is my base? 10. So if this number and this number are the same, my answer is just the exponent. So then this would be negative 3. That's negative 3. So here I've got a positive number and a negative number. So when I combine those or add them, it's really a subtraction problem. That's where I said the tricky part comes in. So I'm going to have 3.0000 and 0.6021. I need to subtract that, not add it, because that's a negative number, that's a positive number. So I'm going to have to borrow, make that a 10 and a 9, make that a 10 and a 9, make that a 10 and a 9, and then make that a 10. So that's 9793.2. But my 3 was negative, so my 2.3 whatever is negative. So my answer is negative 2.3979. Like I said, that's where it's tricky. That because that's a negative exponent, that's a negative number. That's a positive number. When I combine them, it's a subtraction problem. So I wanted to make sure I did that again. So that's 8C. And so then I've got 8D next. So 8D is next. That's log of 42. Well, obviously 42 is not there. So what should I do? Yep. Figure what two numbers will multiply to give me 42. And just like the lady said, 6 times 7. So that's log of 6 times 7. And 6 and 7 are on the chart. So I got log of 6 plus log of 7. Because we know when we multiply those two things that we can separate them. We can say this quantity plus this quantity. So log of 6 is on the chart as 0.7782, and log of 7 is on the chart as 0.8451. And then I just add those together. I line my decimals up and add them together. So that's 3, that's 13, that's 12. No, I don't. But we can look it up. So the answer is 1.6233. It's my answer for AD. Yes, I do. Yep. Mhm. They want you for your meeting, I guess. They want you in the main office. All right, so let's go to the next thing. That was 8. Now we're on what, 9? Okay, let's hit up 9. Okay, 9 is another thing that we go to those properties. So I got 9a. Well, 9a says 3 log of 2 plus log of 5. Now, it says rewrite the expressions as a single logarithm. Well, as you can see, there's 2 of them. Now, one of the properties that we know is that if I have a log of 2 things that are multiplied, that I can write them separately. So if I want to write this as one log, I'm going to do the reverse. I'm going to put them together. There's also a property that says if I have something in front of my log, well, let's not say 3. Use A's and B's. So I got A times log of B. That is the same as log of B to the A power. So what am I going to do? I'm going to change these 2 things and make them 1. So I'm going to say that's log of 2 to the 3rd power times 5. Now, if you stop right there, I might be nice and just give it to you. But you should know what 2 to the 3rd power is. And you should also know what 8 times 5 is. So that's log of 40. Now, in all honesty, we just showed that we could actually get the actual answer for that. That's not what I'm asking for here. The problem says rewrite the expression as a single log. That is a single log. That went from this log plus this log to a single log. And that's what it's asking for. So I'm gonna jump to C. No, you better no, I'll do B and C. So let's do B. All right. So B is log of 2 minus 1/2 of log of 49. So say it again, sir. Yep. So subtraction. If I got log of A divided by B, that can be written as log of A minus log of B. So that's how it's written now. So I need to switch it because I want it to be 1 log. So I'm going to have log of 2 divided by. Now, what did you just say? Caleb, what were you just saying about 1/2 log of 49? What's that? Now, how do we know it's 7? Well, half of 49, yes, but it's remember it's the exponent. So that's going to be 49 to the 1/2 power. And what we know that fractional exponents are what? Fractional exponents are what? Nope, changing position is negative exponents. What are fractional exponents? They're roots or radicals. So in that case, 1/2 is a square root. So that's the square root of 49. So you were definitely right that the answer is log of 2 over 7. So see, that's how I took 2 logs and made it 1. All right. So yes, because it's log of 2. So the 2 is the one that's on top. And then the 1/2 of 49, 49 to the 1/2 power is 49. You take the square root of 49. Square root of 49 is 7. Boom. Yes. Nope, that's 8. 2 times 2 times 2. It's not 3 to the 2nd power. It's 2 to the 3rd power. So 2 times 2 is 4. 4 times 2 is 8. Yes, sir. Fair enough. Okay. Um, C and D, I want you to try, but like I said, this isn't the test yet, so I'll help you if you're having problems. But C and D, I want you to try. All right. So then next is 10. So 10A. 10A says I got log of D times Z divided by F. Rewrite Rewrite the following expressions, expanding them from one log to many logs. So now I'm doing the opposite. So I've got things that are multiplied. I know that I can spread those to two different things that are being added. And then I got something that's divided. I know I can spread that to something that's being subtracted. So just to hammer the point home, this will be log of D plus log of E minus log of F. And that's it. Yes. Guess what? I just did 9C. That that 10A is pretty much the same as 9C. It's just the opposite. It's just the opposite. But I'm saying that I want you to try them, and if you're not getting it, I'll help you. I want to record a video with part of them that I'm doing, and then I want you to have some that you can do by yourself. All right, so that's 10A. I'm leaving 10B for you, and then let's look at 11. Almost there. So 11A. What power with base 5 is 125? So that's 5 to what power equals 125? And I heard it. It's 3. 5 to the third power is 125. Does anybody got any questions on that? That's what power function is. It's the same as log, it's just what power is on there with a label. All right. What about B? So I got 11B is what power? I've got, what is that? 64 is 1/4. So 64 to what power is going to be 1/4? Well, there's a couple things going on. I got a big number that becomes a small number. That tells me one thing about my exponent. The second thing is I have a whole number that's getting changed to a fraction. That tells me two things about my exponent. So big number to small number tells me what? That's going to be a fractional exponent. And then whole number to fraction tells me what about my exponent? It's going to be a negative exponent. So, anybody got any ideas what my number is? That's close. It's definitely negative. It's definitely 1 over. 4 to what power gives me 64? 4 times 4 is 16. 16 times 4 is what? No, 16 times 4. That's 64. So that's 3. So it's negative 1/3. I didn't hear you. Sorry. Yes. Yep. It's negative 1/3. It's 1/3 because it's a big number going to a small number. And then it's negative because it's a whole number going to a fraction. All right. What about C? What's the answer to C? What power of 0 is 10? No, can't do it. Doesn't matter what you do to 0. 0 times 0 is always 0. Doesn't matter what you do. Doesn't okay. Anything to the 0 power is 1. This is saying 0 to some power equals 10. There is no power that's gonna make that 10. No solution. Not available. Can't do it. However you want to say it. Nope. No, you can't leave it blank. If you put nope, I would take that though. Can't do it. No solution. Nope. All right. I'll leave D and let's see, E for you. Actually, F, yeah, because logs and what the power are the same. So if I was looking at this first one, 11A, if I had that as a log, that'd be log 5 of 125. That still equals 3. If I was looking at B, that would be log of 64 is 1/4. Or excuse me, log base 64 of 1/4. Or if I was looking at the other one, it would be log 0 or log base 0 of 10. And you get the same answers. No solution. And this is still negative 1/3. Okay. All right, so that's 11. Last one we got is 12, and then we're set. Oh, my fault. I forgot 13. It's 12 and 13. Okay, so 12A. 12A says, write the log expression in exponent form. So that's log 7 or log base 7 of 49 equals 2. So I want to write that in exponent form. Well, they told us in the instructions that it looks like b to the L power equals x. So anybody got any clue on what it's going to look like? Exactamundo. 7 to the second power equals 49. That's it. Yes, you're doing B. Okay. Whatever. Sorry, 12B. But evidently I'm doing it. Okay, so 12B. It says log of 216 base 6 equals 1/3. I need to rewrite that. It's 216 because that's my base to the 1/3 power equals 6. That's it. That's it. And then finally, I got 13. 13A. That's 7 to the third power equals 343. And the instructions say write the expression in logarithmic form. And that's log of base b of x equals L. So I need to write this as that. So what is it going to look like? Log base 7 of 343 equals 3. And then I'll leave B for you. Yep, that's the answer. You're just rearranging it. You're putting it in a different form. Yep. All right. So that's everything. That's everything. Now, so now here's what I'll do. If you got some questions, I'll record me going over whatever you want to go over. So, let me just make sure I got my paper in front of me. Okay, so what are we looking at? What do y'all want to go over? Couldn't hear a word you said. No, because that's not how it's gonna work. You tell me what problem to go over, I'll go over it. Yo, you don't have a what? That's easy. There you go. All right. So, what do y'all want me to do? 7B. Gotcha. 7B. All right. 7B says 2x to the 1/5 power taken to the negative fourth power. And the instructions say write it in k times x to the nth power form. So that's what I want it to look like. So what do I know about negative exponents? They change position. All right. So yeah, it's kind of late. So anyway, I got 2, yeah, because I did it yesterday. So I got 2 taken to the negative 1/4 power. That's going to be 1 over 16. The negative changes its position, 2 to the 4th power 16. 2 times 2 times 2 times 2. Now, so now I've got x to the 1/5 power taken to the negative 4th power. If I have an exponent taken to an exponent, what do I do? If I have an exponent taken to an exponent, what do I do? I multiply. So I'm going to have 1/5 times negative 4. So I smack a 1 under this. I multiply the top times the top, bottom times the bottom. So that's going to be x to the negative 4 over 5. Now, I'm leaving it just like this because that's what the answer or the question asked me for. It said write it in k times x to the nth power form. That's this. It doesn't matter that 1 or the 1 over 16, that's a fraction because that's the constant. That's k. That's okay if that's a fraction. What I don't want as a fraction is the variable, and it's not. Even though that negative exponent is there, and that would tell me that I need to change its position, that's not what it's asking me for. It's asking me to write it in this format where I got x or my variable as a whole number with an exponent. And so that's what I did. So that's my answer. Anybody got any other questions? What's up? When you had my answers that I was looking at, I said, that's wrong. Yes. So 2D is 6x to the fifth power times 7x to the 11th power times 2x to the fourth power, all taken to the third power. So I'm going to change this color. Can you please move over there? Thank you. So anyway, I made this red for one reason because I've got to take the stuff inside this parenthesis to a power before I do anything else. So I'm going to skip the first stuff and do this. So I got 2x to the fourth power taken to the third power. That's going to be 2 to the third power times x to the 12th power. So let me stop and make sure everybody sees that. 2 to the third power. I'm taking 2 to my power, then I'm taking x to the fourth to my power. There's no exponent there. So that's a 1. 1 times 3 is 3. What? I am just doing what I was asked to do. So that's going to be third power. So 2 to the third power. And then x to the fourth taken to the third. 4 times 3 is 12. Well, what's 2 to the third power? That's 8. So I got 8x to the 12th power. Now I'm going to bring in the other stuff. I got 7 times x to the 11th. And then I got 6 times x to the 5th. So I need to multiply all three of these out. So I'm going to have 6 times 7, that's 42. And then 42 times 8. So let's see, that's 16, carry the 1. That's 32, 33. That's 363. And then I'm going to deal with the x's. I got x to the 5th times x to the 11th times x to the 12th. What do I do when I got the same base and I got exponents? I add the exponents. So what's that? 23, 28. So x to the 28th power. And that's my answer. I'm expecting you to be able to take 2 to the third power and know that it's 8. I'm also expecting you to be able to multiply 6 times 7 times 8. 2e. So 2e is f to the third power over 2f to the 7th power, all taken to the 5th power. So I've got the same base, f, and I've got a division problem. So PEMDAS says first I do parentheses. So I'm going to look in these parentheses. I got f to the 3rd power divided by f to the 7th power. So what's that going to be? It's subtraction. If I'm dividing, it's subtraction. 3 minus 7, that's a negative 4. So I'm going to have, because I'm getting rid of the first thing, I'm just going to put a 1 on the top, have a 2 on the bottom, and that's going to be f to the 4. Or that'll be 2, not 2, sorry. That'll be 1/2 times f to the negative 4th power. Because remember, the negative changes position. A negative 4 means it's in the denominator. So, so, no, I haven't got there yet. I wanted to make sure you understood this. No, I'm about to do it now. So now let's deal with the 5th. If I deal with the 5th with my f in the denominator, it's going to be 1 to the 5th power over 2 to the 5th power times f to the 4th taken to the 5th. What's f to the 4th taken to the 5th? That's f to the 20. And then when I handle all of that stuff, it's going to be 1 over 32 f to the 20 on the bottom. Now, but see, that's the thing. The thing wants k x to the fth power. So I couldn't leave it like that. So let's do it like this. So I got 1/2 times f to the negative 4th power. So I got 1 to the 5th power over 2 to the 5th power. And then f to the negative 4th power. Negative 4 times 5 that's negative 20. So then when I simplify it, I'm going to have 1 over 32 times f to the negative 20. And that's what I want. That's my answer. Because that's in k times x to the fth power form. Anything else? 90. 90. That's log of 3 plus 2 times log of 2 minus 1/2 log of 25. Oops, write that again. So that's log of 3 plus 2 times the log of 2 minus 1/2 times the log of 25. All right, so I got 3 different quantities, right? And it says rewrite as a single log. So I know when I'm adding logs, what do I do? When I'm adding logs, what is it? What? Yes, I'm adding 2 logs, 2 different logs, not adding the 2. Hold on, right here. One of the properties I got is if I have a log plus another log, it's the same as the log with those 2 things multiplied. So there's a couple things. First, I got log of 3 times. Now I got to look at this one. I can't just put 2. What do I got to put? I got to put 2 to the 2nd power. This becomes my power, and that's 2 to the 2nd power. And then I got minus. What does minus mean? Not negative, but what does minus mean? Subtract, but I'm saying as far as logs go, what does it mean? It needs to be in the denominator. I'm dividing. Adding means I'm multiplying. Subtraction means I'm dividing. And so now I got 25 to the 1/2 power. And what's 25 to the 1/2 power? Which is what? Say it, break it down. What is 25 to the 1/2 power? It's the square root of 25. Remember, fractional exponents, those are roots. Your denominator is what root you're looking at. 2 is square root, 3 is cube root, 4 is fourth root, 5 is fifth root, etc. So that's what I got. I'm going to have log of 3 times 4, that's 12 over 5. And that's my answer. So there's a couple properties you need to remember. If I'm adding two different laws together, it's like I'm multiplying the individual pieces of the log. If I have a number that I'm multiplying in front of my log, I can take that number and put it as the exponent, 5. So anybody got any other ones? 4B. All right. So we're talking about the average rate of change. That follows a formula of f of b minus f of a divided by b minus a. And they give us the interval. So let's look at what the problem says. The problem says I got a function f of x equals 2x plus 4. And I'm looking on the interval 7 to 8. So my a and b is 7 and 8. So I'm going to have f of 8 minus f of 7 divided by 8 minus 7. Well, 8 minus 7 is easy, it's 1. But for this thing, I'm going to have f of 8, which is 2 times 8 plus 4. All I did was replace x with 8. And what's 2 times 8 plus 4? Nope. 2 times 8 is what? 16. 16 plus 4 is 20. Yes, you are. And so now I got f of 7. That's 2 times 7 plus 4. What's 2 times 7? 14 plus 4, 18. So I'm going to have 20 minus 18 divided by 8 minus 7. That's 2. Does anybody have any questions on that? That's the rate of change. That is my formula. That's function notation. Any other numbers you want me to do? Hmm. Any other numbers you want me to do on this recording? Last call, because I want to stop it.